Hello, 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 Algebra. The goal for today is to learn how to add and subtract rational expressions. So 7.1, we learned about canceling and simplifying. 7.2, we learned multiplication and division. Today we take a look at addition and subtraction with like denominators. Now, when you have unlike denominators, which is when you have to find the common denominator, that part is in your intermediate algebra. So over here we're only going to deal with those that have the same denominators. The homework will be open for chapter 7 and the single section for chapter 10 that we are going to cover tomorrow. All of the homework for the rest of the semester, right, will open today, and it will remain open for the rest of the semester. And then next week at some point, the rest of the homework will open for you to either catch up, fill in the blanks, right, and make sure that your homework is at 100% for the portion of the grade that it's important. So today all of the homework opens and it will close night before the term ends, which is actually I think the 12th is semester ends on May 12th. So that's when the MyMathLab and everything will close at midnight and you will have no access to do anything else. So let's take a look at addition and subtraction of these things and be done with chapter 7. So we said that the rational expressions are actually fractions which now have variables, right? But before we go there, let's just add 3/4 plus 7/4. This is literally you having 3/4 in the pocket, and then someone gives you another 7/4, and you are going to just add 3 plus 7, it's still quarters, and you will get 10/4. I want you to think of physical quarters because the denominator shows the quality of the object. The top number shows the quantity. The numerator shows the quantity. So when I say 3/4, I literally mean 3 coins. And the quarter is divided by 4, means you are cutting one whole into 4 pieces if you want to understand what that fraction means. So a quarter of something means you cut it into 4 equal parts, and it's just one part is a 1/4 in that case. So what we have now is the situation where we have the like denominator, and in this case we can actually simplify it to 5/2. So we're just going to leave that problem in that way. You can have, let's say, 4/10 plus 6/10. That will add to 10/10, which is simplified into 1, because 10 divided by 10 is 1. So this is simply what we are doing today. We are going to do the same thing, except it will be done with rational expressions. So you will have x's floating about, but as long as you are able to add and subtract fractions, I didn't do any of the, let's say 3/7 minus, 9/7. It's going to give you negative 6/7, because all you do is 3 minus 9. So make sure that you are always keeping the same denominator, because denominators are already like denominators, and those denominators cannot change. You must change them when you have the different denominators, but that's, looking for common denominator is going to be in intermediate algebra, as I mentioned. So what is the situation that you have in this case? Well, you are going to have something like this. Let's say you have 3x over x squared plus 1 plus 2x minus 1 over x squared plus 1. So this is what you are looking at in this case, and it should not be anything scary, because again we are not going to change any of the denominators here or anything like that. We are just going to add the top, right? So we have 3x plus 2x minus 1 over common denominator, which stays unchanged. So now the top is just 5x minus 1 over, and you have x squared plus 1 in denominator. So just go across, right? Just go across and deal with the addition of the values. So x minus, the tablet is overheated. I already had a 2-hour class before this one, so it's just acting crazy. Okay, so x minus 1 over x squared plus x plus 1 over x squared plus x. This is x minus 1 plus 1, and the common denominator is x squared plus x. Now the top adds to just x because minus 1 plus 1 is 0, so that's gone. And denominator is x squared plus x. Now see, in this case, we can simplify, because once you are done with your addition and subtraction, you have to check if the solution you have can be further simplified. And in this case it can, because you can pull x out and then those x's will cancel. And remember, when you cancel everything you have to put 1. So the answer over here is 1 over x plus 1. So once you cancel everything, either in numerator or denominator, or when you are factoring and everything factors out, you always have to put 1. You always have to put 1 there as a placeholder, because when you multiply back, it will have some to multiply into that 1 to give you something, right? So make sure you're always multiplying back. Let's see another example. T squared plus t divided by t minus 1 plus 1 minus 3t divided by t minus 1. So what I have here is t squared plus t, and then I have plus 1 minus 3t, which we need to simplify into t squared minus 2t plus 1, because these are the like terms that I have to put together. And then I have t minus 1 in denominator. Now, it looks like that we can factor on top. And we actually can. It's t minus 1 divided by t minus 1. So one of these will cancel. And the whole expression is just t minus 1. This over here was, again, basic factoring from chapter 6. So make sure that you are factoring when you are able to factor. And you can do one more of this addition, and then we'll switch to, actually here, I'm going to leave this one on the screen and give you 2 minutes to try it. So try this one and see if it can cancel. I'm going to get some water. Okay, let's take a look at the problem. We have like denominators already, a squared minus b squared, and we have a plus b. We can't add them because it's already there. They're a and b are not the same, so we can't add them. Factor denominator into a minus ba plus b, because that's the difference of squares. And now when you cancel the a plus b business, remember, when you cancel everything, one stays behind, a minus b. And we're done. So all of these problems, since you already have common denominator, you only need to add or subtract the numerator. And that's it. Now, subtraction. For subtraction, always use parentheses when you push everything into a single fraction, because the signs have to distribute later. Now, we have simple examples first, like let's say x plus 3 over, I don't know, b, plus, no, sorry, minus, because it's a minus. Let's go with 6 over 6. Let's go with a 4 over b. So if you have this, then it's x plus 3 minus 4 divided by b, which is just x minus 1 over b, because all I have is 3 minus 4. So that's very quick. Pick one from the book. It says 2y over 3y minus 1 minus 3y over 3y minus 1. Again, denominators are already like, denominators are the same, which means that I have 2y minus 3y divided by 3y minus 1, and that gives me negative y over 3y minus 1. The interesting problems are the ones where you have binomials in the numerator. So something like x plus 6 divided by 2x plus 1 minus 3 minus x over 2x plus 1. So for the problem like this, it is really useful and smart to use parentheses so you don't run into issues. X plus 6 minus 3 minus x divided by 2x plus 1. And now you get rid of the parentheses, which is x plus 6 minus 3 plus x. You see, this negative distributed and changed all of the signs in parentheses. So positive 3 became negative 3, and negative x became positive x. The common denominator is always the same. And now x plus x is 2x, and 6 minus 3 is positive 3, divided by 2x plus 1. So writing these second term in parentheses is very important to make sure that you are distributing the signs correctly in the next step. Let's take a look at another example. I'm going to pick up a whole bunch of stuff now from homework. They give you 70 examples to enjoy. So problem 38 says 2x squared minus x plus 5 divided by x squared minus 9 minus x squared minus x plus 14 divided by x squared minus 9. So this is a problem 38 in the book. I think that's the first. No, there are a couple of more subtraction problems before that. That's the first interesting one. So what do we do? Well, we first put all of this into a single problem. So you have your 2x squared minus x plus 5 in the first parenthesis minus x squared minus x plus 14 in the second parenthesis. All of the common denominator of x squared minus 9. So common denominator is called common because it stays the same. It's common for all of these fractions throughout the whole problem. Now, we get rid of the parentheses. So the first parenthesis, you just get rid of it with no change because it was a plus in front. The second parenthesis changes all of the signs. So minus x squared, the tablet is going crazy, plus x minus 14 divided by x squared minus 9. So now we do the like terms. I have 2x squared and the x squared, so they subtract. They subtract into x squared. Minus x and plus x, they actually cancel completely. And wow, that cancels to 1. Because we have the same numerator and the same denominator, right? They're the same. So numerator and denominator are the same, therefore they cancel to 1. Now, for those of you that are more interested in these things and you want to know what does this actually means, the coolest thing here is that no matter which number you pick for x, you can pick -7, you can pick 10 million, it doesn't matter. Whatever number you plug into here for hx, you will always get 1 at the end. So if you want to try that later, obviously if you're interested, you can just go and say, okay, let me see, x is 3. Then you have your 3 squared is 9 times 2 is 18, 18 minus 3 is 15 plus 5 is 20, right? So you can compute, and every time you compute the whole thing, if you use x equals the same number everywhere, you will always get 1 at the end for this problem. That doesn't happen in every problem, obviously. It happens in this problem because this problem has it to be reduced to 1. You can have multiple terms to worry about. I'm going to modify a problem that I see in the book. So 1 plus x over 3 plus x plus 6 divided by x plus 3, and then I say minus 2x plus 9, it doesn't matter, over x plus 3. So you can have a problem that combines multiple, and your job is to obviously bring everything first on the same number, on the same division line. So you have 1, oops, that's not 1 plus x plus 6 minus, the tablet is going crazy, 2x plus 9. And this gives us 1 plus x plus 6 minus 2x minus 9 divided by x plus 3. All right, so what do I have for my x's? I have x minus 2x. That's just minus x. And then I have 1 plus 6 is 7, minus 9 is minus 2. X plus 3. And if you want to flex, you can factor out the minus sign, get x plus 2 in there, and then write it in a cool way. Minus x plus 2, x plus 3. There we go. I'm not sure if my MATLAB would take this, but it should definitely take both of these. On the exam, depending on who's grading, you might lose a point, you might not lose a point. So, factoring that negative is a power move, right? It's a cool thing to do. Let's see, what else do we have? Let's see this number 44. Again, I don't like when they use z's because they tend to be lazy and not cross your z's and then confuse them with 2's and get everything wrong. Cross your z's. Z squared plus 2z. You see, if I just write it this way, it looks like 22. Cross your z's. 2z over z plus 1 plus 1 over z plus 1. Again, for the 50th time, keep the common denominator common. Don't change it. Keep it common. And then the top, we'll just add these. Cross your z's. And now you can see that you can factor the top into z plus 1 times z plus 1. And because it's divided by z plus 1, one of them cancels, and you are just left with z plus 1 over 1, which is just z plus 1. Let me write it out. And that's it. One more problem, and we are, believe it or not, done with this. Tomorrow, we are going to do a section and exam review. We'll have exam for next week. Next week is reserved for office hours and final exam review. And that's the end of the course. You guys, I am going to also leave an option of retaking exam 2 for those of you that are interested. All of the details obviously will be in announcements, and announcements send an email as well, so you'll have all of that info, and then you just do whatever you want. We'll go from there. Let's finish this course, this section, and tomorrow we'll be done with the actual course. Problem 63 says a squared over a plus b minus b squared over a plus b. So this is our problem, and the way we do this is we again use the common denominator. So that's a plus b, and we have a squared minus b squared. Now, by now, you better know that the top factors into a plus ba minus b, and you have a plus b here. They cancel, and you just get your a minus b as the answer here. The homework is posted for chapter 7. This was 7.3 section. We are done with chapter 7. We only have a section from chapter 10 left. The rest of the stuff that we skipped and, worked around, all of that stuff is going to be in your intermediate algebra course if you're taking one next semester. So the rest of the chapter 6, the rest of chapter 7, is going to be in intermediate algebra. So we're done with chapter 7. One section tomorrow at 3 p.m. And we'll also have the review for the test. And the test will be available this weekend for the exam 4. Actually, we can push it for, let's say, Sunday through Tuesday or something like that. So we can push the exam so you can also ask your questions on Monday. So you can ask your questions on Thursday, we'll have the review, then you can practice, do all the stuff. Exam 4 is only on chapters 7 and 10, so 4 sections. It's a quick exam. And that will be it. Then you will pick what you want to do with the final. If you take the final, it counts. If you don't take the final, it doesn't count. And also exam 2 if you want to redo it or you want to keep the old grade, whatever. I will talk to you later. Bye.